So for those of you who don't know me, my name is Steve Davidson. I'm from Raytheon, and in the context of the SOSA Consortium, I'm the vice chair of the steering committee, which is the governing body for the consortium. My intent with this is to get you guys all up to speed on what is SOSA, what we are doing in the SOSA Consortium, a bit about the SOSA technical standard, and to answer any questions you have. We are going to start off by discussing the fundamentals of what is and isn't SOSA. I'm going to tell you a bit about the consortium, the organization, so you understand the context. Those of you who were there this morning heard me comment about some of the foundational things that we had to agree on to begin this process. And I'm going to go over those in some detail because it's very important to have that solid foundation. We are going to talk about the SOSA technical architecture, which is the centerpiece of the consortium. We're going to talk about the business approach. And then there are certain things that you have to know in order to be effective within the consortium having to do with very practical things, and we're going to go over those as well. So, any questions before we start? Good. All right, the fundamentals. As you are probably aware, the National Defense Authorization Act of 2017 mandates that any programs undergoing milestone A or B, beginning this past January, must adhere to the modular open systems approach. Immediately after that went into effect, the Secretaries of the Army, the Navy, and the Air Force produced this joint memorandum that says that MOSA, the Modular Open Systems Approach, is a warfighting imperative. They go on to describe how it's going to be included in pretty much everything going forward, and they cited 4 standards: OMS, UCI, SOSA, FACE, and Victory, all of which you heard a little bit about this morning. When people say modular open systems approach, notice it's approach, not architecture. MOSA is an approach. That's because it has a business aspect, which includes things like contracting language and intellectual property, acquisition processes, and so forth. And it has a technical side, which includes modularity and the use of open systems architectures. Now, there are a bunch of architectures that qualify as open system architecture. I'm listing here the ones that were mentioned in the Tri-Service memo, but there are many, many, many architectures out there. So when you say MOSA, you're referring to an approach. When you're talking about open systems architecture, OSA, you're talking about the way those are instantiated in the technical documentation. Okay? The word architecture is often confused. So I'm going to explain what we mean by architecture and how it differs from design. So this is my favorite definition of architecture. It's an IEEE, ISO, IEC definition. Fundamental organization of a system embodied in its components. We're going to use the word modules here because we're about the modular open system approach, and their relationships to one another, and those relationships are interfaces. So everything in MOSA, in terms of what we're doing here, and at SOSA, are based on the concept of modules and interfaces. A lot of people confuse architecture and design. Think of it this way: a design is an instantiation of that architecture, and there are many ways of instantiating. I'm going to do some examples in a bit, but there are many ways of instantiating an architecture in specific designs. So when we talk about what we're doing in SOSA, we are developing a reference architecture that can be used to instantiate a whole wide variety of systems, and that is the whole point. And my little bumper sticker is that what's really important is that we are not generating a point solution. We are not generating a description of a system. The whole idea is to have this unifying architecture that covers as wide a variety of systems as possible. And you this morning heard the government desirements on that, and they'd like to see it doing everything from soup to nuts. Ideally, if you're talking about a radar, it'd be great to be able to develop an architecture that applies to everything from a Joint STARS class ISR sensor down to a police radar speed gun. There are practical implications for those, the wide scope.
So, I think one thing about design, first thing I think of is like design school and user interfaces and commercial definition of design. Why do we use design when we're talking about instantiation?
So you talked, and I'm going to repeat the question for video. So when you're talking about things like user interfaces and so forth, those are actually instantiations. And in fact, the user interface is actually outside the scope of what the SOSA technical standard is going to define.
Okay, so I think a designer might disagree with you on your definition of design.
So as we go into architecting and architecture and what a reference architecture does for you, I'm going to give you some clear examples of the difference between architecture and design. Okay. As I mentioned before, we want to think in terms of modules and interfaces. So what is a module? A module is a grouping of functionality encapsulated in a module that exhibits certain behaviors. So it performs functions and exhibits behaviors. And those modular entities then interact with other modules in a system over key or well-defined interfaces. Those interfaces could be signaling, they could be physical, thermal. There are a whole lot of definitions of what, or examples of what you might be about interfaces. But if you think in terms of defining an architecture of a system in terms of major building block elements and then how those building block elements interact with one another. And there's some criteria, and we'll talk about the SOSA criteria for how you decide what your particular modularization needs to be, how you group things and why you group them. And then that's a very, very important thing to cover, and we'll get to that. So I'm kind of laying the foundation. So I've already mentioned that modularity encapsulates functionality and behaviors. Ideally, and one of the tenets of MOSA is that those modular entities are tightly integrated within themselves, but if in all practical purposes loosely coupled from one another. Now the word open gets abused a lot. It's kind of like free. What do you mean by free? We're talking about free beer, free software, free and open. And in fact, there's an essay out on the internet, if you can search for it, called 50 Shades of Open. We're going to use the terminology and the definition based on MOSA documentation. And there are three things that you need. There's a lot of paperwork there, but it all boils down to three things. That the definition of the architecture is widely available and published. Great, but that's not enough. There needs to be a consensus-based process for governance and definition so that their terminology, interested parties, have an opportunity to participate and influence the process. And that's why we have this consortium. And the third thing, and you heard a bit about that in the opening session this morning, is that there's a conformance or compliance validation process that ensures that if you say that you are using an adherent to that standard, that you really are. You all familiar with the term Wi-Fi? You probably also heard of IEEE 802.11g. So the IEEE is an organization that developed the standard. How do I know that my widget that speaks 802.11g and your widget that speaks 802.11g actually can interact? Well, we can both build something to the standard and hope that it's going to work. Industry group was formed called the Wi-Fi Alliance, and they defined a set of tests that determine and prove that interoperability. And the word Wi-Fi, you cannot put that Wi-Fi sticker on your device unless you have been proven you can prove that you've passed their tests. If you try to use the word Wi-Fi and they haven't, just as the Open Group would do for the SOSA trademark, they will come after you. So this conformance process is actually baked into MOSA documentation. If you claim open, you have to have all three. There are organizations that publish their own internal standards and say, this is, insert name of company, open. That doesn't make it open. Just because you publish it doesn't mean it's actually open. One of the things that's critical in the concepts of open systems architecture is the gray box concept. And you probably noticed that, and not by accident, that little picture here. All of these boxes are gray. What do you mean by the gray box concept? The gray box concept says that the standard defines what the functionality is and defines the interfaces, but it is absolutely silent on how you instantiate that process. So Inside the gray box, it's not a black box, because I know what the functions are. It's not a white box, so I don't know what you did inside there. But I do know that you encapsulate these functions. So I'm going to give you an example, and we're also going to get into the design versus architecture. I have here, behind the podium, an invisible lamp. You guys can't see it, but it's really here. Now this lamp has 3 modules. I'm going to unscrew the top. There's a shade. I'm going to put the shade aside. We're not going to worry about the shade. But you know that I can buy another shade and replace it. It's beige. I'd rather have white. Cool. I have a base. It has a little wall plug that's dangling on the floor here. And I can plug that into the wall. That's one interface. And the other interface is a socket. It's an E26 socket. E for Edison, because Thomas Edison actually invented that. In the US, we all get light bulbs from that. Now, unless I bought this lamp, I can unscrew the light bulb. Let me put it down so it doesn't break. I'm sure I'm going to get in trouble for that statement. So unless where the lights are physically, soldered in, I can replace that light bulb with a new one, especially if it burns out. It's very important. Okay? So the three modules here. One of the modules is a light bulb. Now, how is that light bulb instantiated? I could have instantiated this light bulb by taking a thin piece of tungsten and putting it in an evacuated envelope, glass envelope, and running a current through it, and that tungsten filament gets hot and I produce light. I could also instantiate this light bulb with this one, which has this, you can't see it, but it's a little curly Q of glass, compact fluorescent. Or I can pick up this light bulb and attach to the E26 base is a little power supply that turns 120 volt AC into 5 volt DC, and then soldered in there is a whole bunch of little LEDs, and then it has a diffusive cover. 3 different designs, 1 module. So, differentiation between design and architecture. I think you guys get the idea. The beauty of this is I don't need to know General Electric's formula for generating that tungsten filament in order to replace that light bulb. So you can see how this factors very nicely into the concepts behind MOSA. The government wants to buy the systems made up of modules where the functionality interfaces are defined, but we don't want to give away the IP, and they don't need to know the IP for them to replace this module with another. An example of this in your everyday life is your car. You have a radio system in your car, and there was a time where you could just replace the head, the radio head, the audio system, the AM/FM radio cassette deck with a third-party one. You can add a cassette deck to a car that didn't have one and not have to replace the entire dashboard because of that idea of upgradability. And that's part of the concept behind MOSA and why the government wants MOSA in all of the procurements. So I've answered your question. Okay, so the question was, I'm repeating for video, there are some concerns about the interoperability between modules and different instantiations, and how do you ensure that you don't have you can mitigate interference. Okay, so first of all, one of the ways you mitigate interference is to make sure that you can manage and coordinate the operation of these things. Those have to be built into the architecture. If the architecture doesn't take it into an account, which is why that was brought up this morning, so things like resource management to ensure that if you're sharing an aperture, that only one function is operating in the aperture at a time. That has to be baked into the architecture. It's an architectural consideration. Now, when you deploy a system, there's nothing in the architecture that says that this antenna has to be within or this far away from that antenna. That when you're looking for co-site interference, that's an instantiation question. You need the architecture to be able to monitor when that happens. But as you instantiate that, that's a design issue. It's outside the scope of what the architecture can define. Just as every lamp has a little sticker on it that says, don't use bigger than a 60-watt light bulb. There's nothing that prevents some person from sticking a 120-watt light bulb and burning their house down. Okay. All right. So our approach for SOSA is make sure that we've got everyone who has a stake engaged. So this is not one of those programs where it's by invitation only. We've got all the services engaged, we've got industry, we've got other government organizations, and we've got academia. Our goal is to develop one unified technical architecture that addresses radar, EOIR, SIGINT, EW, and communications. Now you might say, wow, wait a minute, those are all different. Are they really? They all emit and receive structured energy. They process that energy, and they turn it into information or action. They might be somewhat different at the place where they're receiving photons. That is, EOIR is very short wave. Radar, EW, SIGINT, and communications is usually radio frequency. But once you've collected that energy and turned it into electrical signal, there's a huge amount in common between those. And that's what we're doing. We're leveraging that commonality. The why is, you heard that this morning, better acquisition, better upgrade. I know my organization is very interested in that because we want to build products around standards so that we don't have to invent, because it's more expensive to invent than it is to reuse. And we're doing that through this modular open systems architecture that is SOSA, by defining these functional aggregations as modules and defining those interfaces between them. Okay? Faster, better, smarter, right? That's what everyone's after. We want to be able to, you heard the discussion this morning about lifecycle support, the upgradability. You heard, you know, it's cost effective. It's cost effective on both sides. National Defense Strategy mandates a change in how we acquire systems. The government acquires systems and how we develop systems in response. And interoperability. The idea that you can build something that is useful across multiple things in terms of portability, and because you want to build things that can work with other things, that they're not isolated standalone. I love it when I see charts like this. This is our architecture, a lot of people will put up. Right? They'll have a bunch of boxes that are going to be arrayed like this, and you know, they won't label them A, B, C, D, but that's what they say. This is not an architecture. Anyone want to venture a guess as to why it's not an architecture? Nobody wants to venture a guess. Okay, I'll give you a whole bunch of reasons. First of all, it tells me absolutely nothing about how A interacts with H, or whether it even interacts with H. This isn't even a good wiring diagram, because if this is supposed to be a network, you know that we don't use the old style thick net that existed when I was young. That, you know, you had a big fat wire and everybody did a vampire tap into that wire. No, we go to switches and hubs. And so this is not even right, because these things are all talking to a concentrator. This is not an architecture. This doesn't tell you anything about how the system functions. You cannot build a system based on this. So what do? Well, our approach is to use DODAF. Raise your hand if you break out into a cold sweat when you hear DODAF. A lot of people do that. Okay. It's not so scary. The Department of Defense architecture framework is simply a decomposition of the description of a system in terms of aspects. When you have an architecture for a house, you have a plan view. The carpenter will use that to do the outside part. You'll have a plumbing view, which tells the plumber where the pipes go. You'll have an electrical view. And then the architecture of the house is the combination of all of those. You can build a house based on those. That's what DODAF does. It divides the system up into different ways of looking at it. Some of them are physical, like the systems viewpoint, and we're going to talk about the SV1 for SOSA. Some of them are functional, like the services viewpoint. We'll talk about that. Some of them have to do with things like the capability. We're going to talk about that first. What are the capabilities? And some of the material that you heard this morning relates to things that we have built into the capability view for SOSA. So all DODAF does is allows you to take the system, a complete picture of the system, and look at it from different perspectives. Okay. So let's talk about the capability view number 1, or CV1, for SOSA. The CV1 was essential when we started this, because we had people from all sorts of organizations with all sorts of perspectives, all coming in with a completely different view of what SOSA was going to be. And we needed, if we're going to make any progress at all, we absolutely needed to have a unified view of what is SOSA and what we're doing. So, you probably already read the vision at the top. It's business practices and technical environment that engages. We've developed a cost-effective system that can be reconfigured, and you heard some of that this morning in the plenary session. The goals are to make it open, to make it standardized, to harmonize with existing standards, to align with DoD policy, to be cost-effective, and adaptable. Again, all of which you heard this morning. Now, for each one of these, there are a set of enabling capabilities that are essential to get you there. Right? The idea is not just to have a bunch of vague wish lists, but actually put that into practice. So, for each one of these, there's several things that are the enabling capabilities that are the things we do to make that happen. So, under open, we're developing an open systems reference architecture through a consensus-driven process. So we achieve number 2 of the 3 things that you have. There's a business model that enables that. The acquisition community has to be able to buy what we're architecting here, or it doesn't make any sense. From a standardized perspective, we're leveraging existing standards as much as possible. And you're going to hear, those of you who are going to the hardware working group later, you're going to hear a whole lot of VITA, a whole lot of host, a whole lot of CMOS. We're going to create what's new only when necessary. And again, consensus basis. Harmonized. What do we mean by that? As you heard this morning, there are a lot of standards, and someone asked the brilliant question, and it was a great question. Is the intent to just keep making new standards? And the answer is no. SOSA is being viewed as the unifying standard, and what we are actively doing, and when we talk about the organization, you'll see that there's a working group that is set up specifically to align different radar architectures in SOSA. So we're trying not to make yet another standard when we don't need one. And there's a great XKCD cartoon about that. I would love to put that in here, but I think there's a copyright violation. Yeah. So the question is, are they adaptable? We don't know what will be 2030, but the intent by having a standards organization is to evolve over time. And I think you heard, they talked about this morning that there's a road mapping activity going on to continuously update these things. One of the things we're doing, though, along those lines is trying to converge. So different standards are evolving, and so I've been involved with several others, and what we're trying to do is we're trying to move them all towards a direction of convergence. That is, there are things in this one that we don't have. So when I get to the modules, I will give you an example of one where we changed what we're doing in order to be better aligned with an existing radar standard. Yeah?
The fundamental what's and whys tend to remain constant over a long period of time. This is what the customer needs. The hows change.
Yes, and the specific technologies. So the concept of standardizing on connectors, thank you. So the concept of standardizing connectors isn't going to change. The idea is that as new connectors with more capability come online, those then become part of the standard, and we'll end up deprecating some of the older stuff just to keep things manageable. Aligned. Well, you know what? In the interest of time, all of this is on Plato, and we'll come back to it. But in every one of those cases, the idea was that there are reasons why we're doing things and how we're attempting to accomplish them. I can't claim we are getting there. We do have some challenges with a large organization like this. We have we have large system sensor providers. We have parts and element suppliers. We have acquisition organizations. We have government we have different parts of the government, all of which have their own perspectives and needs. So there are changes that we have to address. We have to deal with the fact that existing contracting language doesn't really it's not really amenable to what we're trying to do. So the contracting guide offers alternative contracting language to make it possible for someone to, an acquisition organization, to buy a system based on the SOSA technical standard. We formed this consortium officially, was it a year and a half ago? We are operating in an informal way, incubated under the FACE consortium for a while before that. And we're moving towards developing the business architecture as well as the technical architecture. This is the org chart for the SOSA Consortium. So there's a steering committee that's made up of organizations that are at a particular membership level, and they are ultimately responsible for final decisions throughout the consortium. We have two standing committees that operate across the consortium. The use case standing committee is developing and officializing the use cases that we are using to test whether we're accomplishing things in the architecture that we intend to. And there's a technical standards coordinating committee that takes all of the working group outputs and makes sure that when it goes into the technical standard and the draft technical standards that it's consistent and well coordinated. We have an architecture working group, a business working group, hardware, electrical, mechanical, and software. And for each of those working groups, or almost each of those working groups, we have a number of subcommittees. These are long-term standing bodies that address important aspects for each of the working groups. So the very first one we stood up was security, and I think it's pretty obvious why the security subcommittee was established. Fundamentally, we want security to be baked in, not bolted onto the technical standard. There isn't a separate security architecture. There are security aspects to everything. Several other subcommittees exist. You'll notice data model is light here. We intend to stand that up. It's just a matter of time, leadership, and manpower. Under business working group, we have conformance and outreach. Hardware has this thing called system management, which originally began as essentially chassis management and has grown from there. We're going to talk about management in a little bit. And then the radar, it's called officially the radar, but it's actually the radar framework alignment subcommittee is working across multiple radar standards to try to achieve alignment by making changes to our technical standard to align with the others and making changes to the other technical standards to align with SOSA. So we're trying to find that happy medium. Our makeup is industry, a lot of defense, and as well as commercial, and then we have a whole bunch of DoD and other governmental organizations participate. Our membership is divided up into sponsor level and principal level members. These organizations are part of the steering committee. And then associate level allows us to be as widely available to small organizations as well as large organizations. And yes, last night I updated this with the new organization. Mike left. He's our membership guy, and he just announced we have a new member. Trouble for me is this list keeps growing and growing and growing, and I'm running out of space. Every working group has a chair and a vice chair. These people are elected by the membership. So I'm the vice chair of steering. Ilya Lipkin, you guys all met this morning, is the chair of the steering. And the purpose of steering is essentially to be the decisional body that represents the consortium as a whole. Our business working group is chaired by John Bowling and vice chair George Dalton. By the way, you'll notice that in almost every case, we have one industry and one government person. That has not been, it hasn't been architected that way, it's just how it's turned out. Because of the level of involvement. This is a government-industry collaboration. You're going to see a lot of combined teams. The architecture working group is kind of the technical integrating element that pulls together all of the parts of the SOSA technical architecture. Again, government and industry working together. Electrical mechanical is the only one that doesn't have a government person in the lead role. Their function is to ensure that electrically and mechanically we have a sound architecture. I'm going to be talking about the products of all of these working groups, which will be a lot more interesting. Software working group, again, government industry team, and their responsibility is the software aspects of things, especially as it relates to the interaction between and the interfaces between the modules. And then the hardware working group has focused quite a bit on plug-in cards. In the Vita world, you'd call those modules, but in the SOSA world, for reasons that hopefully will become extremely apparent in a moment, we refer to them as plug-in cards. And then finally, the use case standing committee, and their job is to collect, adjudicate, and flesh out all of the use cases that we are using to test out whether the architecture makes sense. I will not talk through, but every one of the subcommittees has a charter and and is well defined. By the way, these charts are on Plato, and I'll show you where they are in a little bit. We also have these things called task teams. Now, what is a task team? Task team is a short duration, small group that's supposed to go off and figure out something and then come back with what they think is the answer. They're specifically to be short duration. So security is going to be with us forever, but we have a number of task teams that are out to answer one question only, and then evaporate. And that's to make sure the organization doesn't keep growing and growing and growing. Okay. So let's get back to the SOSA technical standard and our approach. We recognize, and I've been on standards bodies where everybody comes up with their cool idea widget and you kind of build it up, bottom up. You don't build a ship by throwing a bunch of deck boards and so forth and sort of one molecule at a time. You build a ship by laying a keel, add some ribbing, start putting the decking in, start putting on the hull, then you fill in the inside. Our attempt is to do the same thing, is to build the structure and then fill in the structure, the details. So we are following a top-down approach, and we are following the DoD MOSA guidance that I showed you before. This chart was formulated probably 2 years ago, maybe 2.5 years ago, as to our process. We started out by saying, who are the stakeholders? Who cares about what we're doing here, and who needs information from the SOSA technical standard? We developed a consumer product matrix, and I'll explain what that is, but essentially, if you are following DODAF, you don't do AV1, then AV2, then AV3, then SV1, then SV. You don't do that. You define what you need, and you don't do all of those representations. So the question is, what do we need to produce in order to generate a technical standard that people can develop to? We identified our objectives. We developed quality attributes. You're going to hear about those in a little bit. We developed architecture principles. We developed and then stopped developing use cases. You'll notice this is yellow. And we are still talking use cases. The history of that was that we started down this path, and it was a long path, and we weren't getting these things done, and people felt that we were getting behind where we should be. So we stopped where we were. We started doing this, and now we're going, oh my goodness, we need more of this again. So we are back to generating use cases, hence the discussion this morning, hence the meeting this afternoon, the business drivers leading to things like the backplane meeting tomorrow. I was very involved in the FACE Consortium for most of its early years, and we learned a very big lesson then. Every product of the FACE Consortium had its own glossary, its own dictionary. And when you start looking at those dictionaries, we found that some of the definitions did not match. They didn't even look the same. So with SOSA, and by the way, the FACE Consortium has since reversed that. They now have one integrated AV2. But we started out saying, we're not going to do that. We are going to have an integrated dictionary and all the terminology to make sure we're all speaking the same language. Because within a big organization, if you're not speaking the same language, you're not going to accomplish anything. We defined the system boundary. We started defining, and then we did define the module, and we're working our way through defining the interfaces between modules. So that's the big picture of where we are, color-coded. I mentioned that one of the first things we did was to identify who our stakeholder community was, and then what are their informational needs. So this is very hard to read. I'm going to zoom in a moment. But for each category of consumer, we identified what their informational needs are. So an engineering organization within government is going to be interested in what the functional decomposition is. A validation organization is going to be looking for SOSA unique certification activity, and they need to know what the system behaviors might be, etc. So zooming in a little bit, what we did is we said, okay, for each information need, these are the artifacts that you could produce, and where do you have an intersection? So someone who needs to understand the SOSA technical architecture and interactions, and especially engineering use cases, are going to need these products. And someone who needs how it can help program managers, high level of information, etc. So then what we simply did was we looked at where the intersections are and where we found a preponderance of need, and we said those are the artifacts that we need to generate in the first round for the first version of the standard. So we identified what we are doing before we even started. So this is the development roadmap for the different products that we are doing. You know, CV1 we've done, the AV1, AV2 is all done. The conceptual data model, you're going to see we've done that, et cetera, but we're in the process of defining the logical data model, and we have little fragments of the physical data model. So what does that all mean? Okay, so let me start us back on the previous flowchart and say quality attributes. Quality attributes, they're not quantity attributes, they're quality attributes, are the things that you use to evaluate the goodness of the architecture in the context of the use cases. So what do you want out of your architecture? So there are 10 quality attributes that we have for SOSA. And by the way, quality attributes are also rank ordered. So interoperability trumps portability. You say, well, why is that? Well, the result was the result of a lot of deliberation and a consensus. You can't have it all. You have to sometimes make trades. Now, if it's on the quality attributes list, it's still part of the evaluation. I'm not saying that the one at the top always wins. In fact, you tend to be banded. So our quality attributes are interoperability, securability, modularity, compatibility, portability, to be continued. And for each of the quality attribute, and you probably can't read it from the back of the room, but it says, what do you mean by capability or compatibility? And then there's a statement of, in the context of the SOSA architecture, this quality attribute, in this case, refers to the ability of SOSA systems to be used with or integrated with systems not designed to align to the SOSA reference architecture, or with systems designed with earlier versions of the SOSA standard. So we have backward compatibility. So what do you mean by it, and what are the implications for the architecture? And all of our decisions are couched in those terms. So if somebody comes up with a great idea, it's evaluated against this and some of the other foundational criteria. The other ones are plug and playability, upgradability, scalability in two contexts, sensor multiplicity and host size. Because when you say scalability, what do you mean? And we had two different interpretations. And then resiliency. And what do you mean by that? Refer to build a SOSA system to be able to maintain operations while under duress caused by physical damage, electronic interference, or cybersecurity attack. So those are all of the quality attributes that we baked in. Another foundational concept are architecture principles. And architecture principles are guidelines to the people working the architecture. So we've got, it's not like you have one architect, you're all architects. As far as the consortium is concerned, you're all architects. So the architecture principles address, some things are business related, some things are technical. You know, so you know, every SOSA hardware element has defined physical interfaces. Modularity is fundamental, interchangeability is fundamental. Each of these is described. There's actually a lot more information to it. What is the rationale and what are the implications? And I am not going to read this to you. Please read this on your own, but what it is, the statement of what you mean, what is the rationale, and what are the implications for the SOSA technical standard. If you integrate all that information up, you will essentially have the stuff that Jason was talking about this morning. Earlier on, I said we were doing radar, EW, SIGINT, EW, and communications. And I posed the question, geez, well, that's a lot of stuff. I mean, the whole point is to be able to maximize commonality. The back end, and I don't like that term, but the back end of an EW system or the back end of a SIGINT system is doing pretty much the same thing as the back end of a radar. If you're working with a SAR image and you're working with a photographic image, you're doing the same thing. You're geolocating, you're rubber sheeting it, you're moving things around so that your image matches geographic references and so forth. So our objective is to maximize the commonality between systems, because ideally you would have a SOSA sensor that's multi-headed, that might have a SAR and a SIGINT sensor in one head, so you've got maybe two different apertures all feeding the same processing chain and working together. The AV2, the Integrated Dictionary, this is just little pieces of it, so some terms that are very important. A hardware element is a general term. A plug-in card is essentially something that slots into a backplane. A SOSA plug-in card is not just any old one, but one that actually conforms to the SOSA slot profile. A software component is a chunk of software, and then a SOSA module is an architectural entity that does the business of what a sensor does. So one of the reasons why we don't use the word module to refer to a plug-in card is a single board computer lacking software doesn't do what a sensor needs it to do. You need that tracker, you need that, you know, the threshold detection, you need all of those functions of a sensor to be operating. So a module in SOSA speak is the functional aggregation of the things that need to be done in order for a sensor to work. And we'll talk just about that. A little bit of DODAF here. What is an SV1? How many of you heard of the term context diagram? A few of you. Okay, so you can think of an SV1 as an example of a context diagram. And I'm going to skip a lot of the words here, but I'm going to go to a picture. So the way you would instantiate a SOSA sensor physically from a very, very top level is you'd have a whole set of hardware elements that connect with other hardware elements, either potentially through a pod or associated with a host platform, that communicate using various interfaces. Some of them are digital, some of which are analog, some of which are cooling, some of which are power. And the way you build a SOSA sensor, it doesn't have to be a monolith. You could have some of the you know, the apertures could be on the front end of an air vehicle, and all the processing can be aft inside. The key is that these elements communicate to each other by way of not custom wires, because we're trying to get away from custom, right? It's supposed to be modular, but through a set of interfaces that are defined by the electrical mechanical working group as the interfaces that connect pieces of a SOSA sensor together. So that you can replace this aperture with another aperture because it has commonality at the interfaces. Okay? There are actually two versions of this, one where the pod is entirely within the sensor, and some where the pod is just a host to portions of the sensor. So when you talk about what is a sensor, it's essentially something that does one of the sensor, performs the sensor functions, or a combination of them, as in a multi-ent or a multi-headed system. A hardware element is a major physical building block of a sensor. Could be an aperture, it could be a chassis. Host platform. How many of you guys thought before just now that SOSA was all about airplanes? Good, okay. Because the host platform can be air, could be surface, could be essentially subsurface, I suppose. We haven't explored that yet. Could be a building. I mean, why not? Put a SOSA sensor on a building. The host platform can be anything. And the idea is that what we want to do is we want to make sure that that sensor could be applied in different environments. There are certain things that are inside the envelope that functionally the sensor does, and certain things that are not. So I mentioned user interface before. All of the data is there, but for the SOSA Consortium to define a uber user interface that'll work on all systems makes absolutely no sense at all. Now I've heard some of the customer community say, well, we really want to be able to have a defined user interface. Define it, put it on a Raspberry Pi, have it external to the SOSA technical standard, but include it in your acquisition. There's no reason why you can't do that. Okay. So, remember, we are talking modular architecture. Modules and interfaces. So, when we talk about a SOSA module, we're talking about something that aggregates the functionality of what the sensor does. Hence the terminology SOSA module. How we got there? Well, there are a lot of ways. In fact, very, very first or second, maybe the third meeting we had, we asked a radar person, an EO person, and an EW person to draw a block diagram of their typical system. And there were some similarities and differences, but there were differences. So we asked the question, well, why are you doing it that way? Well, that's how we do it. Well, why are you doing it this way? It's just, traditionally, that's how we partition things. So I said, well, let's break things down into their constituent functions. So we started out with an enormous list of functions, and we began to aggregate them. We began combining them into modular entities based on some criteria that we decided ahead of time. Has to be severable with minimum complexity interfaces, can stand alone, independently testable, does not expose intellectual property, and encapsulate rapid change. To your question about upgradability, if you've got something that you expect to be upgraded quickly, you want to make sure that that's in a standalone module rather than having to rip a module apart because technology gets better. And then we identified what information needs to come from outside the module to feed the module so the module can do its work, but we don't care about the internal interfaces within the module because that's part of the secret sauce, that's part of your IP. Okay. Again, gray box concept. We specify what the modules do. We do not specify how it's instantiated. We've had a lot of discussions where we get into instantiation space and we have to blow the referee whistle and say, stop, this is a reference architecture, not a system architecture, not a system design. So we've identified a couple dozen modules. Each one has a number, like module 6.9, a label, a description, a list of functions, a set of inputs and outputs, and all of this is, you're going to see snapshot examples of it. Okay? So this is the list of SOSA modules. And we've grouped them by category. So these are all, by the way, none of these, I shouldn't say none of these, we are not setting things up so that you have to have all of the modules. This is a superset architecture. So for example, if you've got an EOIR sensor that only needs to send images to the ground, you don't need things like situational assessment and storage retrieval and impact assessment. Those are important for certain types of sensors like EW, but you're not going to necessarily instantiate that in a simple EOIR sensor. It's a long list. I'm a visual person, so I prefer the graphical representation, and I'm going to walk you through this. So we have two management modules. One is called the System Manager. It's an unfortunate name. It really focuses on things like health and status, housekeeping functions within the sensor. The other one is the Task Manager, and we'll talk a little bit more about that, but the Task Manager is the thing that communicates with the outside world and receives the look over there at that object or update a track. So the Task Manager worries about the sensor operation as a sensor. The System Manager focuses on making sure all the pieces are working, that, everything's lubricated and has a voltage and so forth. Your question. So the question was, how does software and hardware overlay? And the answer is, so typically done, now you're into instantiation space. So one of the things we're working very hard to do is to make sure that if you want to implement something in software, or he wants to implement it in firmware, that we're not locked into, oh, he can't do that because we said it's going to be in software. A lot of these functions, these modules, can be instantiated solely in software, like the tracker. Some of these functions are implemented in some combination of hardware and software. What we're trying not to do is tell you how to do it. We're trying to tell you what it needs to do and what interfaces need to be exposed for the purposes of ensuring that you have a successful system design. Repeat the question for the video. What about interoperability and plug-and-play ability? So a lot of efforts going on right now to figure out a way of, for example, abstracting things from firmware so that it could be implemented in firmware or software. And at build time you worry about it, but you don't have to, it's not a situation where the architecture locks you into one solution or not. So that's a hard problem, but that's also one of the reasons why we're still working on interfaces. Because we're trying. Say again?
Is the architecture hard point?
One of the architecture hard points is to not force a particular form of instantiation. Transmission and reception, we've separated receiver and transmit so that you can have, for example, radar warning receivers and you don't have to carry the baggage of transmit. We have a group of modules that deal with processing and signals, so image pre-processing or object characterization and then tracking. This module used to be integrated with this module. The number is 3.4. You would think that would be numerically earlier than image pre-processing or whatever, and the answer is no. We had it integrated, And Frost, which is an open architecture approach to, it's an Army architecture, came to us and said, we think that we'd like to have trackers separated, we'd like to converge, we want to be aligned with SOSA, that's the only place that we're really different. We had many discussions, we worked out the implications, we decided it was a good idea to do it, and the tracker is now its own module. I already mentioned analysis and exploitation, and then there's a set of reporting services, and then we have this support or service functionality, security, encryption, time, nav, calibration, and the host platform interface. The role of the host platform interface is to allow us to be agnostic to what you put this on. This side of it can speak OMS. There's a number of things we're looking at. OMS is the first one that we're working on. But the idea is you don't need to bake OMS inside the SOSA sensor in order to speak OMS to an outside and to be part of an ASB. Okay?
What happened to 4.5?
I've forgotten. It's been a while.
Did it get removed for some reason?
No, we did a refactoring. We realized that there was, in the SIG and EW community, there was a standard decomposition, and we were not aware of it when we did the initial. Okay. So we did a refactoring about 1.5 years, 2 years ago that then realigned these to an existing body of knowledge because we want to be harmonized. So it wasn't that we dropped this one out. We actually chopped 4 things into 3. So for each of the modules, and this projector is really kind of fuzzy, but we developed a Service View 1 and the Service View 4. And the Service View 1 defines what each module does. So there's the tracker. It describes, and then the functions themselves, the inputs and the outputs from each module are captured in the Service View 4, which is an enormous table that I think we stuck in the appendix of the snapshot just because it was such an enormous table. From an interface perspective, I usually, with apologies to my networking and communications friends, the OSI 7-layer model is a little bit of overkill. We don't have a presentation level session. So we look at it from a physical, a protocol, or a signal or data content perspective. And you say, what do you mean by protocol? You guys have all been on the phone with somebody and you're reading a phone number. The phone number is, 555-121-3456. And the other person's saying 555, wait, say it again, because you did it all at once and you expected them to read it back. And in fact, you might have said, I'm going to give you the first 3 digits and then pause, and you're going to say, and the next 3 digits. So that's the protocol. So we wanted to make sure that when these modules interact with each other, the protocol used is not necessarily tied to the content of the communication. So our approach is top-down. We defined a conceptual data model, DODAF speak div 1, that identifies what kinds of information exchange. The logical data model that talks about the content, and then we are working through, we're still not done with this, and we also have the physical data model that defines the specifics of how those bits are communicated. So little endian, big endian, we talk in double precision floating point, we talk in integer. We want to separate these. We want to say the what, and this is more like the how. And for the same piece of information, you might represent it 2 different ways depending on what your application is. Again, if you go right into message land, then you lose all of that. And then we talked just a moment ago about the protocols. When you say what are the messages, well, the messages is the combination of the protocol and the data payload. Okay. There are a number of ways that modules interact. And we've categorized those as essentially like architecture patterns. Some of them are analog, some of them are digital, discretes. Some of them interact through a publish and subscribe methodology where one source provides the information and a number of elements will receive and process those. And some things are request response. That is, please, put your coffee cup down. Okay, I did put my coffee cup down. Thank you. We're done. I don't want to say to the whole room, put your coffee cup down. I just wanted him to do it. So that's not a publish and subscribe. That's a command response. And I get a no kidding, I got it response, then I know it's been done. So request response is very useful for things like management. Publish and subscribe is very useful for data dissemination, like a track track information is going to be useful for a number of modules within the SOSA sensor. And we're not hardwiring. You notice the diagram I had didn't have direct lines between things, because you might instantiate things different ways. And the idea is to make it as flexible as possible, but have these well-defined interfaces. So certain information is going to be under publish and subscribe. You know, certain things like, again, management functions are event notification, a failure, or a radar warning receiver wants to get the word out. So IQ, signaling, pre-digitization, a analog feed from a IR sensor is another one. So the question was asked, give me an example of an analog distribution. I should have repeated the question. So our data model was divided up into two pieces, the management entities and the mission entities. The management entities have to do with things like faults. The mission entities have to do with data detection and information collection. System management is a complicated beast. Sensor management is the bigger picture. Sensor management is all of the things that the sensor has to do in order to do the job of a sensor. And so the host platform communicates to the host platform interface. And again, we don't want to tie that to any particular host platform. The Navy uses different things than OMS, for example. Host platform interface sends things like health and status information back and forth to the system manager, which communicates with the hardware elements and the modules. The task manager gets the tasking information, look over there, do that thing, collect this data, give me the answer to my question. And the task manager also speaks to the modules. And also there's a interaction between them. One very important aspect of the task manager's job is resource management. Task manager has to, especially in a multi-int situation, but even in a typical radar situation, the task manager handles mode selection or request from the host platform for a particular radar mode or EW technique. There are a set of services that operate within the manager. We're not defining how they're going to be. We just say that there has to be something there that receives information, and we have a sort of client-service relationship defined, both up above and then from the managers down to the individual modules, which I don't show. Oh, I do. There we go. I want to move a little more quickly because I'm looking at the clock. The software environment is at this point somewhat in a state of flux, and we're hoping that this week we can get things nailed down. It has been decided that we're going to match what the FACE consortium is defined as the interfaces between the operating system segment. How many of you guys are familiar with FACE technical standard? Just 1, 2, 3? Okay. So we're taking pieces from FACE. We are now addressing how we're going to interact between modules, and one of the candidates to that is some instantiation or a light version of the FACE transport services. Transport services segment in FACE is extremely complicated, partly due to the very, very complicated nature of the FACE data model. And so what we're talking about, but it has not yet been decided, is whether a light instantiation, or light version of transport services. So it does some of the same functionality and allows you to use DDS or Corba or whatever your sockets as the means, but it abstracts that away. But we're not, we're defining units. That's one of the big differences between what we're doing and what they did in FACE. We are using SI units, and we're defining them in the logical data model. I'm going to skip that because there's just too many words. Let's talk about the hardware. Hardware, they've been working at this sort of chassis level or box level. And a lot of work in the hardware working group has been to harmonize with VITA, CMOS, and host, and also to define slot profiles. And what slot profiles effectively do is say this pin is going to be used for this purpose when it plugs into the backplane. And that is tremendously valuable with a standard like ours. Even though the module itself isn't defined by the single board computer, for example, customer wants to be able to upgrade to newer generations of single board computers. They want to be able to acquire one that they know is going to be a one-for-one replacement, maybe better, faster, smarter, but speaks the same way to the backplane as the old one. And so a huge amount of work has gone into doing that. There are a number of, there's a lot of work going on into defining the interaction between the plug-in cards. A lot of adoption of Vita, Host, and CMOS. For a while their power was a question. Now they've settled on 12 volts or 3.3 volt aux. And the backplanes themselves are going to be 3U and 6U. And there's a whole catalog of plug-in card profiles for those that enable a system to be upgraded, reconfigured in the field, specifically because of the compatibility and portability afforded by the plug-in profiles. Electrical Mechanical Working Group is focusing on connectors and mechanical interfaces. They began with this taxonomy of mechanical, cabling, and environmental specs. They have identified a whole raft of approved connectors. They started out using the SPIES standard. SPIES is a Navy standard for turreted EOIR sensors, and have expanded on that to include all of the features you would need regardless of the sensor type, added connectors, sped things up with high-speed Ethernet and so forth. And this is outside my field of expertise, but essentially every connector, what it's for, how it would be used to standardize the mechanical and electrical aspects of things so that you can build up a SOSA sensor, so that you can have an aperture out front and processing in back, and the connection between them being standardized in such a way that you can replace that sensor, the sensor head in front with a different one, and still have the compatibility with everything that's interior and aft. All of this gets rolled together in the SOSA technical standard, and we have, as you heard, Snapshot 2 has been published. Snapshot 3 pens down in just a few weeks. The way it's structured is there's some overview material and what is actually the definition of the standard itself with requisite shalls, and then a set of appendices that have lots and lots of tabular information and all the details of the slot profiles and so forth. And I strongly encourage you to read the front material in the technical standard. It'll amplify a lot of what we've talked about in here. I can't say that it's exciting reading. It's not. But it contains everything you need to know. A little bit about the business process. The business model for SOSA hasn't been completely worked out. It is a work in progress, and the business working group needs help. So those of you who raised your hand earlier, please help. One aspect of the business model is that if you're under contract to build something using the SOSA technical standard, you are expected to, if you identify any flaws, gaps, is to report back to the consortium what you found. We want this to be a living, growing thing. We do not want this to be static. We want it to be able to keep up with technology. And the way people wring out these issues is when they actually use them. We know it's not perfect. It's made by humans. Humans are not perfect. So part of the business model is to advance it through the acquisition process. And that just goes into a little more detail. Taking a page from the face verification process, if you say my module, I think this is SOSA, this is going to be conformant to SOSA, you need to be able to verify that yourself. You need to then take it to a verification authority who then does a run for the record, and if they actually do, then the certification authority then can put that Wi-Fi sticker on it, or in this case the SOSA sticker on it, and then that could be put in a registry optionally, so others know that you are selling a widget that has the SOSA seal of approval. You saw when you did your registration the little trifold. That's a little handout that describes what we're doing here. We have an outreach organization that is helping to get the word out, although it seems to be getting out pretty much on its own at this point. Okay, so let's talk about how we actually operate in the consortium. Now, by now you've all onboarded. You probably all signed up to be part of a working group, subcommittee, or something. So a couple of things that I really want you to do. If you have a video camera attached to your computer, please unplug it before you start it, because WebEx really, really wants to put your picture up there, and what you'll get is a black square, and everyone will have to deal with a black square. So disconnect it, because we're not doing cameras. Secondly, and I'm going to make, I wish I could just make this flash, log on to your computer first. You say, well, why would that matter? When you log into the computer, it tells you how to dial in. When you dial in and you put your participant ID number in there, it associates your phone number with your login. So have you guys been in conferences where it's like, who's speaking, whose voice is it? Well, you don't get that if you do it right. And that is, this computer, when you're talking, your name will appear. I don't know if I don't think anyone was talking at the time, but you'll see sound waves, or there are different ways it represents depending on what mode you're in. Who's speaking? So you never have to ask who's talking. We have to take attendance, because we have to have a record of who participated. If you dial in before you log in, then you show up as call-in user N, where N is some number between 1 and 1,000 or something. And then they have to go, who's call-in user 3? Somebody talk who didn't, do it right, and now you don't want to do that. You want to access it from your computer first. So the beauty of the WebEx thing is when you're in the conference, you have there's typically somebody who's presenting material. It's either canned or live, and there's a chat that you can have to provide supplemental information. And that turns out to be very useful. But the beauty of this is it's full contact. It works very well. I will say, though, if you're using the internal speakers on your computer and you're taking notes, please mute your speaker, because what happens is your speaker, your microphone, especially on a laptop, is typically in the case. So you hear thum, 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 thum. And because you know who's talking, everybody knows you're the one who's typing. So you really want to mute. Okay? The other major tool we're using is this thing called Plato. How many of you guys have tried Plato? Okay. It's a web-based system. I'm going to just walk you through a couple of the features. Over here on the left are the organizational entities listed. And if you select one of them, the whole rest of the screen will be oriented towards that organizational entity. So member level stuff here, steering committee, architecture working group, electrical mechanical working group, etc. Okay? We're not seeing it right now, but you'll originally come up to the home screen. I'll show you the home screen on the next slide. The place you're going to do most of your SOSAfying, I know I can't use that term, but I had to slip that in there. You can bleep that out. Is the Documents tab. So this is a reverse chronological list of the documents in this area. Certain ones are, you see the little push pin there? Certain ones are bleeped out, are pegged to the top. The AV2, for example, is here. Okay? And so there are certain things like the AV2, you want to stay at the top of the list. You want it to be accessible all the time, so you make it sticky. So to look for something from a face-to-face from 3 years ago, you're going to have to scroll way, way down.
I just want to emphasize that I took a while to figure this out. When you click on the left, that Documents tab on the right is a different Documents tab. Yeah. So every other link on the left is a home page for the same set of links.
Yes.
Across the top.
Yes, this defines everything else. And so, and searches are unfortunately only within a particular view, which is a little unfortunate. This little plus guy here means that there's multiple versions of that. So this is the AV2. Every time we update it, we make sure that we keep the historical record of the past instantiations of the terminology. I already mentioned the thumbtack. The home page looks like this. So in other words, the first tab looks like this. And there are a couple of things that matter. One is there's a calendar, and each one of these little dots is actually a link to that particular meeting on that day. And by mousing over, you can see okay, this is the hardware working group meeting. You can click that and go to the page for that, and then you can use that to join the hardware working group meeting on that date. A record of all of the emails that go to the distribution lists are here. So this one you're only showing 3, but there's something, I can't see it, but there's a button there that brings you a page. You get the whole history. All of our official correspondence is documented, and if you miss something, you can always find it there. There are certain areas here that are a little more special. Temporary documents. Now, what is that for? A lot of stuff we'd really rather not email around. Some of those things are sensitive, but you don't want to put it on the archive and have it there forever. So instead of emailing it or doing something tricky, what you do is you can put it into temporary documents, and then I'll send you a message saying, here's the link to the temporary document, you pull it off, and then let me know when you have it and I'll clean it up. So that's a repository that allows us to share ITAR sensitive material. Now those other two on there that are labeled distro D, no more. Plato was authorized for ITAR, but actually wasn't authorized for distribution D. So all of that stuff is moving to the VDL, and I'll show you that in a minute. So I don't know the official date for when this is all going away, but everyone should be getting a VDL account, and I believe that's part of the onboarding material now.
So question about that.
Yeah.
I've had a VDL for a long time. I just requested access to the SOSA over there. How long does that take before you get?
Probably a day, because what happens is that request gets sent to a whole bunch of people.
Well, maybe I already have it then. And I just
I don't know.
I'll check.
I get those requests, but I've never actually done that stuff. I got added to the privileged user list. I get those requests, but Ilya's the one who's been clicking the OK list. We're going to talk about VDL in a minute. I just want to show you a number of things that are kind of in that required reading list. Things like the SOSA architecture principles, which are now in the snapshot, the CV1. Those show up on the SOSA members page. And certain things like the quality attributes, the system view 1, and the service view 4 have also a home here. I may take this out of this presentation because now I basically say read the first 5 sections of the snapshot. And that's probably the best thing to do. Document review. So in a few weeks, you're going to get some information that says, hey, there's a document there that you probably ought to review. How do you do that? So there's a tab that says Review Documents. Not documents, but Review Documents. When you hit that tab, there's a click here to display Review Document. When you click that little guy right there, it brings you out to a window that shows the text in a really kind of weird way where there are these little bracketed numbers, and then next to every paragraph in a bracketed number is a little quill pen. That's how you comment. My personal preference is to grab the Word version of the file, mark it up myself, and then have that open on one screen, and on the other screen go in there and then replicate my markings in here, because you lose some formatting and some other things when it's represented this way. But what you do is you click on one of those quill pens, and then you have to fill in information. And the information you have to say automatically fills in who it is. But you say, what do you want to do? Like this paragraph, phrases reads like bullets. So change it to actual bullets. That's what this person's comment was. Now this is an editorial comment. You can have technical comments. And you have to indicate something about severity. Don't use the most severe form, because that basically means it's the nuclear option. That is, if you don't do what I say, my organization is to take its marbles and go home. That's kind of what that is. So nothing ends up being critical unless it's like huge. But that's the process you're going to use to provide input to documents. And we use this very, very effectively all the time. Now, about the VDL, how many of you have VDL before? Who else? You do? Okay. So you know that, and you'll have my programs at the top, and they're my programs at the bottom. And you click in there, and it'll take you to a page. This is the initial page you'll get to for SOSA. It's the main page. There's a whole lot of stuff here. Please ignore. Why? Because the UDRI helpers that were helping set it up started doing the wiki. Well, we're not using it for a wiki. The VDL is strictly for distro D documentation. So go to the shared file area, ignore that stuff. When you get to the shared file area, you're going to see something that looks like, traditional folder system. And you double click on any one of these, you go in, you can dig around deeper and deeper. It's a fairly intuitive interface. For example, yesterday this I forgot what this had, but it got changed to scratch drive, and then I appended temp storage will be deleted. Don't put anything here. This was where the original zip files that they used to move things over from Plato went. But all members, hardware working group, radar, This is the radar subcommittee and the security subcommittee. All right now have distro D content, so it's on the VDL. Everything else lives on Plato. Okay. So, I hope you found this informative. I do want to emphasize that this is a modular open systems architecture. We're trying to do top-down. We're following the gray box concept. It's very, very important. Our success in this effort depends on everyone's engagement. There are a lot of people who will dial into meetings, and that's it. Please don't be like that. Participate constructively. Volunteer to help out. If everyone volunteered just a little bit, we would be able to move that much faster. So I strongly encourage you to, just dive in. It's interesting, and don't be afraid to ask questions.